We were working on this problem where we were given a graph of a function, as you can see, and we were trying to find some information about it. The last thing we did with this function was we figured out how many times the line y is equal to 2, y is equal to 3, and y is equal to negative 2 intersect the graph. That was part I of the problem. Now let's look at part J, K, and L. Part J says, for what values of x is f of x greater than 0? For what values of x is f of x less than or equal to 0? And then finally, for what values of x is f of x less than or equal to 4? So let's zoom into my graph. Let's figure out where 0 is. So remember that f of x is the y value. Here's the y-axis. So we want for all the values for which y is greater than 0. That goes with this piece of the plane. Because here's 0. So we want all of the x values that when we plug them in, our y values lie above 0. Okay, so if we look at the graph, obviously this piece of the graph is above 0 and it stops right here. Then from here to here, we're less than or equal to 0. And then from here to here, we're above 0. So the x values, remember, we're going to write them in interval notation. We're going to start with the smallest number. The smallest number x can be, because remember values of x is this axis here. So we go all the way out to negative 7, and we can equal negative 7. Then from negative 7 all the way to 1, negative 1. But we don't want to equal 0. This says greater than 0, and at 1, this negative 1, we're equal to 0, so we have to put a parentheses here. Union, from negative 1 all the way to 6, we are less than or equal to 0. But then from 6 to 7, we are greater than 0. So from 6 with the parentheses, because we're not equaling 0 here, to 7. And we can equal 7 because the point right here is above 0. Okay? For what values of x is f of x less than or equal to 0? Well, here's 0, and we want less than 0 or equal to 0. So from negative 1 to 6, we are less than or equal to 0. And we can put brackets on negative 1 and 6 because we're equal to 0 there. So for this problem, this is negative 1 to 6. I'm going to erase this. The next problem says, for what values of x is f of x less than or equal to 4? Let's find 4. It's right here. Let me do it a different color so we don't confuse it with the graph. So we want the values of x that were less than or equal to 4. So anything in this region. Okay, we start with the leftmost number. Well, our domain goes all the way out to negative 7, but you can see at negative 7, we're above the line y is equal to 4, all the way to here. Now this point, I haven't colored in my graph, but we're going to make a guesstimate. You can see that it looks like it goes through right here. So if I bring this down to here, remember this is negative 7 because every 2 counts as a unit. So this is halfway between negative 6 and negative 7. So negative 6.5. So from negative 6.5 all the way to here, well, this is right on the line, and we can be equal to 4. So we can include this x value at negative 3 all the way to the end of our domain, because all of that is under 4. So all the way to 7. So from negative 6.5 to 7. Okay, let's move on. Our next topic is holes and gaps in a graph. So holes are exactly what you think they are. Here I have a graph with a hole right here. And that means that I don't have a colored in point. There's no point at this location. Okay. Can you find the domain and the range of this function? So we have a parabola, and I have all the points on this parabola except for this one point. Let's see if we can find the domain and the range. Okay, so domain is all of my x values, so from the left to the right. Let's put that in a different color. We start with the smallest number we can be. So remember, this graph is going up and to the left forever. So we're going to keep going, and all the way to negative infinity. If we have like a negative 20,000, if I drew a line all the way up, this thing is going to keep going up and to the left, keep going up and to the left. We're eventually going to cross that line. So this is going to be from negative infinity. Then as we come in this direction on the x line, you can see that we're going to be going down on this graph. Then we're going to hit 0. Let's zoom in a little bit. We're at 0, and then when we come to 1, there's a hole. So we don't have anything at 1. There's no point here, so we have to take that number out. And then at 1, after 1, any number after 1, as we go this way, this is going to be going up and to the right. And so as we go further and further out, this graph is going to keep going up and to the right. So this is going to go all the way to infinity. Let's talk about the range. This one's actually a little tricky if you're not careful. Remember, the range is how far up and down you go. What's the lowest point on this graph? Well, that's at the origin here. So the smallest number my y can take on is 0. What's the largest number, or do I have any gaps? So as I go up, you can think right here, so halfway between 1 and 0, which is a half, you have a problem right here. However, on this side, we have a point. So as long as when you see a y value, somewhere on the graph you have a point, then it is in the range. So as we go up further and further up, you can see that we have points, and this is going to continue on forever. So the range is 0 to infinity. Now if I had another opening right here, then I would have to take out this point, which is 0.5. I would have to take that out. But because I have 2 points, one that, well, this one's not a point, but I have this one over here, it's in the range. So that was a hole. Let's look at a gap. So a gap is like this, where we make a jump. Now this is actually the equation of f of x, or a sketch of the equation, over 1 over x squared. And the idea is these two lines here, if I continue this y-axis, they're going to get closer and closer to the y-axis, but they're never going to touch the y-axis or go over it. So they're just going to keep going up and up, this one up and up. So they're going to get really, really close to this line, but they're not going to touch it. And then this line right here, you can see that this graph is doing almost the same thing here, except for it's horizontally. This is going to get really, really close to the line y is equal to 0, but it's not going to cross. If I had the ability to zoom out, then you would see that this is going to continue going up, and this is going to continue going closer and closer to this, but it's not going to touch. So this is considered a gap, right? Because you're drawing your graph, and you have to make like a big jump to get over here. So do we know what the domain and the range of this function is? It is a function, right? We've seen this one already. If we draw vertical lines, we only go through it one time. So the domain, remember domain is left and right. This is going on forever. So the domain is from negative infinity. Then as we come in from negative infinity, we can see we have points on the graph all the way. Well, the closer and closer you get to 0, this is going up and up and up and up, and it's going to get closer and closer to the line. So the only number you can't equal is this 0. So we have to take out that 0, and then we make a jump, and we go from 0 to infinity. Because now we're over on this side. As for the range, remember the range is how far up and down you go, and we start with the lowest possible number, and you can see at 0, this thing is going to get really close to 0 on both sides, but it's never going to cross this. This is called an asymptote. And this one here is an asymptote as well. We get really close, but we don't touch or cross. So the smallest number we can be is, well, you can't actually be 0. You can get really close to it, but you can't equal 0. So we're going to have to put a parenthesis here. And then this is going up forever. So as we go further and further up the y line, we're always going to have points on both sides. So it's going to go up to infinity. All right. Now we're going to look at some equations. Here I have the function f of x is equal to x plus 7 over x minus 3. So no longer are we looking at graphs, we're going to play with an equation of a function. Of course, we can try to graph this by plotting points, or we can use a scientific calculator and graph it. But I want to know if we can find the domain and some other information from just the equation. So how do we find the domain? Now we've done this before. Remember, the domain is all the values that x can be. So we think about what it cannot be. And since we have a fraction, the only time we're going to have a problem with a fraction is when the denominator is equal to 0. So x minus 3 can't equal 0, which means x can't be 3. That's the only number that we're going to have an issue with. If you put anything else here, you're going to be dividing by anything but 0. So this is the number we have to take out. So the domain is negative infinity to 3, 3 to infinity. Something else I want to know, is the point 2, 1 on the graph? So if I was to draw the graph of this, would it go through this point? Well, remember that this is the x coordinate and this is the f of x coordinate, or the y coordinate. So all I need to do is plug in 2 into here and see if this simplifies to 1. Let's try that. I'm going to put a little bit of space here. So f of 2, because remember this is the x, this is 2 plus 7 over 2 minus 3, which is 9 over negative 1, which is negative 9. This point is not on the graph because I should have a negative 9 here. So the answer is no. Part C says, is the point 1, negative 4 on the graph? I'm going to do exactly the same thing. I'm going to plug into the function 1 and see if I get negative 4, because this is the x and this is the f of x. So f of 1 is equal to, let's look at the equation, x plus 7, x minus 3. So 1 plus 7, 1 minus 3, right? Yeah. So that is 8 over negative 2, which is negative 4. This number is the same thing as this number, so it is on the graph. So the answer is yes. Let's try another one. Got a few up here. I think I'm going to copy the function so I don't have to scroll up and down so much. So let me do that. Let's copy that. And let's put it here. Okay. If x is equal to 3, what is f of x? Well, this is exactly what I just did a second ago. So you can say f of 3 is equal to 3 plus 7 over 3 minus 3, which is 10 over 0. Okay, so this is not in the domain. Before I had even done this, I should have remembered what numbers were in the domain. Because this is not in the domain, we're going to get an error. This is undefined. So it's not in the domain, so we actually can't evaluate the function at this number. However, if I gave you any other number, like 5, you could just plug it in, and you can see that you won't get a problem. You'll be able to find the point, and you could just say, like, if it was 5, if you wanted to find the point on the graph that corresponded to x is equal to 5, you would just plug that point in, that number in, and that would be your point, 5 comma f of 5. Okay, let's look at another one. Here's the function again. Yeah. Put some space here. If f of x is, didn't we just do this one? Oh, no, what's the difference between these two? Here I have, if x is 3, what is f of x? This one says, if f of x is 3, what is x? Do you see the difference here? Here, this is the y value. And I'm saying if y is 3, or this right here, I'm setting this part equal to 3, and I'm trying to solve for x. Can we do that? Yes, we can. So let's put a 3 here, and we get 3 is equal to x plus 7 over x minus 3. Now what do? Well, let's multiply both sides by x minus 3. We'll get 3 times x minus 3 is x plus 7. Distribute, you get 3x minus 9 is x plus 7. Add the 9 to the other side, you get 16. Subtract the x, you get 2x. And so you're left with x is equal to 8. You can always plug it back in. 8 plus 7, that is 15. 8, 7, 6, 5 divided by 5, that is equal to 3. And we got one x value, which is important because that means we have a function. So if f of x is 3, x is equal to 8. And so we have this point, 8 comma 3, because it's x comma f of x on the graph. I think these are the last, these are the last two problems. Let's scroll down a little bit and let's put our function here again. I want to list any x and y intercepts. How do I do that? Well, let's remember what the x-intercepts are. That's when y is equal to 0 or f of x is equal to 0. So we set this thing equal to 0. We get 0 is equal to x plus 7 over x minus 3, and we want to solve for x. So multiply both sides by x minus 3, and you get 0 times x minus 3 is x plus 7. Distribute, you get 0 is equal to x plus 7, so x is equal to negative 7. So this is the x-coordinate of your x-intercept, and you can write it as negative 7 comma 0. That is your x-intercept. It depends on what your homework asks you to do. If they ask you to write it as a point, you would do this, and if they just want the x-coordinate, you would just say x is negative 7. Now what about the y-intercept? The y-intercept is where we plug in x is equal to 0. So f of x is x plus 7 over x minus 3. Plug in 0, f of 0 is 0 plus 7 over 0 minus 3, which is negative 7 over 3. So that tells me what the y-coordinate is. So the y-intercept is negative 7 over 3. And you could also say 0, comma, negative 7 over 3. You could also say this is f of 0. One more question. What are the zeros of f? Remember, the zeros of f are the x-intercepts. So zeros of f are the x-intercepts, which tells you that the x-intercept, we actually only had one, which was negative 7, 0. So x is equal to negative 7 is a 0 of f, because f of negative 7 is equal to 0.